P5. Today we're looking at fractional expressions, and I know you guys have done domain and range before, so try to remember for yourself what the difference is between domain and range. We're going to focus on domain today, so hopefully you're thinking that domain is the set of real numbers for which an algebraic expression is defined. Okay, again, the set of real numbers for which an algebraic expression is defined, meaning you know we can't divide by 0, you know we can't take the square root of negative numbers, those kind of things. Those are for what they would not be defined. Okay, so move that up a little bit for our directions. So these are going to say find the domain of the following expressions. Okay, so this first one, right? Quadratic. You may want to think about the graph many times, okay? So you need to start, when you see a problem like this, when you see that, you need to think quadratic and you need to think parabola. So a hint about that is definitely to think about the graph and about what values of x you're allowed to use in this expression, okay? Now I think you guys realize that a parabola is a nice smooth curve. You don't ever pick up your pencil. It has arrows, it goes on forever. So it should make sense from the picture that you would be able to plug in anything. But think about this expression here. Okay, is there any problem plugging in any numbers that would cause any issues? Okay, and if you think through it, you can plug in anything, square it, multiply it by -7, add 12. Yeah, it's not going to cause any issues. Okay, so in previous classes, you may have said x equals all real numbers. That symbol is just like a double bar with like a fancy capital R. If we're going to practice, we will practice because we will sometimes ask you to do that in interval notation, and I think some of you guys still need that practice. So you would just be telling me that x equals, so that I know it's an interval and not an ordered pair. So x equals, well, all real numbers, if you think about the number line, would be parenthesis, -infinity to infinity, parenthesis. Okay, so we will write both of those down just for practice. So next then, let's try these 3 problems. And at the end, you'll see me box the answers that I think are going to show up in your workbook. Okay, the format, but again, we're going to practice both of those formats. All right, so number 2, we're taking the square root of something. I'm going to put it that way. If you think of this as the square root of something, and the something is whatever's under here, don't you agree that the square root has to be the square root of something positive, right? That something has to be positive. You can't take the square root of a negative number. No even roots of negative numbers. So what you're telling me is if you put that in an expression and turn it into an inequality, if x minus 4 has to be positive, that means it's got to be greater than or equal to 0. Now, why do I add equal to? Well, the square root of 0 is 0. Okay, so that is allowed to equal 0. All right, you would add 4 to both sides, right? And you get x is greater than or equal to 4. This is probably the format they're going to give you, so I'm going to go ahead and box that. But again, if it was an interval, you guys should be good at telling me, well, for the domain, the x is, if I'm bigger than or equal to 4, then I'm going to have a bracket at 4, and it's going to go to infinity. Okay, that would be your other option. All right, number 3, then 4th root. So again, it's an even root. Again, that's telling me that whatever's under that root must be positive, so greater than or equal to 0. And if we solve that, right, we're going to subtract 2 from both sides to get -2. I'm now going to divide by -6. What do you do with inequalities? When you divide or multiply by a negative, flip the sign. Okay, so now this is going to turn into x is less than or equal to 1/3. Again, I'll box that because that's the format we'll probably use for this worksheet. If I'm equal to 1/3 or I'm smaller than it, and you write that as an interval, you guys would be telling me that x interval is parenthesis, -infinity to 1/3 bracket. Okay, keep practicing those. All right, in 4, I kind of like to think of when it's a fraction, the top and the bottom separately a little bit, okay? And then think about where they overlap. So I hope you're thinking the top is linear, right? If you just wrote a y in front of that, y equals x minus 7 is a line. I hope you realize you can plug anything into a line and not have an issue. So the domain for the top, if it was by itself, would be x equals all real numbers. Likewise, if you think of this one by itself, y equals x plus 3, that's a line. That would be x equals all real numbers. However, let's add the fact that it's in a denominator. Okay, I'm allowed to plug in anything for x except what makes that denominator equal to 0. I cannot divide by 0. So I think you guys will see that x cannot equal, right? There's your symbol. X cannot equal negative 3, implying it can equal anything else. And then if you think about where those two overlap, right? Even if you thought about drawing a number line. So the top one's all real numbers are filled in, and the bottom one is everything's filled in but negative 3. Where do they overlap? Everywhere except negative 3 in words. How do we write that mathematically? You'd probably tell me x equals all real numbers, but means I'm going to put a comma. X cannot equal negative 3. Now that would be a very detailed answer, okay? In the future, it's understood, guys, that if you just write x doesn't equal negative 3, that implies it equals anything else. So you don't really need the x equals all real numbers, okay? Think about that as a number line, because I still need you to be able to do that as an interval. So I'm going to just quickly draw this to help you. Here's negative 3. That would be an open circle. Everything else would be filled in. Okay, so if you're about to write this in interval notation just to practice like we've been doing on the others, I hope you're realizing it's going to take 2 intervals to cover that. Okay, the left interval would be, and you again would be telling me x equals, but the left interval would be parenthesis negative infinity to negative 3 parenthesis, comma, parenthesis negative 3 to infinity parenthesis. Okay, there we go. A couple definitions we need to know. So a fractional expression is the quotient of 2 algebraic expressions. So an example would be like x over 3. A rational expression is the quotient of 2 polynomials. And yes, that means a rational expression will have variables in the denominator, such as 2x minus 1 over 3x. So to simplify or reduce rational expressions, again, here's where you need to be super good at your factoring. So hopefully you're getting a little bit faster at it. Okay, factor both numerator and denominator if possible, and then cancel any like factors. That's going to be a big thing. That's why it's in capital letters. Remember, factors are terms that are multiplied together. Okay, all right, so here we go. Right off the bat, I hope that you are recognizing the top is difference of perfect cubes. So you should be changing this into x 2 x squared 2x 4. I'm just hesitating to give you a little bit of time to fill that in. And then minus, plus, and plus. So you've got to be pretty quick at that now. Remember, the trinomial never factors, so that's nice. You don't have to worry about that trinomial on the top. The trinomial on the bottom, play around with it a little bit. What's going to add to be negative 6 and multiply to be 8? Hopefully you're going to get x minus 2 over x minus 4. And then the big thing here is that factors are multiplied. So you've got to take entire factors. So notice these have an x minus 2 that would cancel. And nothing else. Okay, nothing else. So your answer is going to be x squared plus 2x plus 4 all over x minus 4. But stop and don't box it. Okay, don't box it. We are not finished. What you got to get used to, we're going to put a comma, is in a problem like this, automatically, without being told, you've got to worry about a domain. Okay, and the reason being, there are things that could cause issues. Remember, you can't take square roots of negatives or even roots of negatives. You can't divide by 0. Okay, so we need to worry about things. All right, so understand that there are differences in the way books are written. There are differences in the way teachers teach this. Okay, so I'm going to cover you for wherever you're going next, okay, at Cherry Creek High School or elsewhere. And that is the following. So some teachers are going to say, I want to see the complete domain. And others are going to say, I want to see what is not obvious. Here's what I mean by that. A domain comes from the entire problem. It comes from not only the final answer, but also the work and the original problem. So to me, the only thing I have to worry about here, guys, are denominators. If I know this denominator can't equal 0, it's much easier to look at it in factored form. So I'm going to look at it in this step. This is immediately telling me x cannot be, from this step, x can't be 2, and it also can't be 4, because both of those factors would turn into 0, and I would have an issue. Okay? To me, I prefer, so for my class, you're going to show me true domain. So your answer is going to be, comma, x cannot equal 2 or 4. There's a full answer. That's what I want from you. Okay? But understand, some of your worksheets and some of your teachers next year may say, or they're going to put the domain as x cannot equal, and the only number they're going to put is 2. And the reason they're putting the 2 is they're saying it dropped out somewhere in the problem, and so you can't tell that x can't equal 2 here in the final answer. But it's obvious in their mind that x can't be 4 because it's sitting right there still in the answer. Okay? We'll keep practicing that. Please do for me what is in blue. All right, next problem. First things first, guys. I would say when you guys are trying these problems, make sure whatever you do, always make your squared term positive. Okay? So that should be your tip off, that the very first thing you're going to want to do in that top is take out the negative, and at the same time put it in descending order, right? You always put your x squared before your x before your constant. So if you factor out a negative, you'll have x squared minus x minus 12. Now it's in a nice format for you. All over, if you want to go ahead and factor the bottom one, you can. So what multiplies to be 2x squared? Well, it's going to be a 2x times an x. And then again, you're playing around with it, figuring out numbers that when combined with that 2 will end up giving you the -9 and the 4 in the appropriate place. Okay. So again, play around with those numbers and hopefully eventually get -1 and -4. Remultiply it out to make sure that you're set. Okay. Continuing on, multiplying or factoring, I should say, the top. The negative is just going to hang out front. You should be getting x and x. What multiplies to be -1 and adds to be -12. Should be looking at -4 and -3 over the same denominator. And now that everything is factored, we're ready to do some canceling if there is something. Remember, we cancel full factors. So I see x minus 4s are going to go away, leaving me with, you can just leave your negative in the top, guys, so there's no debate about it being in the bottom, times the quantity x minus 3 all over 2x minus 1, comma, you automatically have to know to put in a domain. Okay? Miss Barber wants the full domain, which means it's from every single step. Okay? Every single denominator cannot be 0. So I'm really focused on every step, but I notice there and there, it's going to give me the same thing. X cannot equal 4 or 1/2. Okay, so there's a full credit answer for my class. What are the other teachers going to do that only want to see the ones that are not obvious? Well, they're going to put, so this is the other option, they're going to put the domain is x does not equal 4, because they're going to say it's obvious that I can still see that x can't be 1/2 from the final answer. Okay, so they're again only focusing on the ones that canceled out during the problem. All right. Next, operations with rational expressions. So when you're multiplying, factor all your polynomials, numerator and denominator, cancel any like terms on the numerator with anything in the denominator, and then multiply straight across. So again, canceling can be any numerator and any denominator. Okay, they can be above and below, they can be across from next to each other. Okay, and we'll see that in the next one. And then dividing, okay, I think you'll be convinced of this, but let's make sure. You should be multiplying by the reciprocal of the second one, guys, but let's kind of convince you of why that works. So for example, when you're dividing something by 2, you're really cutting it in half, right? So we know that cutting 3 in half, written this way, is the same as this, right? We're saying there's 3 and you're dividing it by 2. But you should algebraically agree that that's the same as 3/1 times 1/2, okay? In other words, 3 divided by 2 is the same as 3 times 2's reciprocal, okay, which is 1/2. And that's how we divide things, right? So if you took 3 pies, you divided them into to give to up to 2 people, how much pie would each person get? I know you can tell me the answer would be 1.5, but ultimately, if you are really thinking about that in terms of improper fractions, that would be 3/2. Okay, really the important part there is that 3 divided by 2 is the same as multiplying by 2's reciprocal, which is 1/2. Okay, so here we go. Let's do an example. All right, so I have these 2 fractions being divided. So I'm going to keep the first fraction and start doing some work at the same time. Okay, so my first fraction is going to be, I want my squared term always to be positive. So I'm factoring out that negative and turning this into x squared minus 4. I don't want to do too many steps at once. The denominator, I'll go ahead and, well, let's go ahead and factor it. Okay, we've seen those numbers quite a bit before. So numbers that multiply to be x squared, you'll have the x and the x. And then if you want the number to add to be 7, -7, and add to be 10, I'll have my -5 and my -2. I'm going to change this into multiplication right now. And always, just so I don't mess things up at the end, especially for the domain, all I'm going to do is just find the reciprocal of that and not do anything with it yet. Okay, in the next step, I'll go ahead and do more. So I'll leave the negative here. You should see that as difference of perfect squares. So x plus 2 times x minus 2. The denominator staying the same, x minus 5, x minus 2, times, hopefully you now see this as just there are 3 of these. Okay, but it's already factored. That's factored. And then hopefully you recognize the bottom as sums of perfect cubes. So that's going to turn into x plus 2, x squared, minus 2x, plus 4. Okay, put that over that. Remember that trinomial from that cubic never factors further. That's the nice thing about that. Okay, everything is factored. So now I'm ready to do some canceling. You can cancel anything on the top with anything in the bottom, the full factor. So 1, I notice the x minus 2's cancel. Next, I notice these x plus 2's cancel. Next, I notice I have some x minus 5's that will cancel. So I can cancel one of them from here with one of them from here. So I'm just changing that exponent to 2. And now I'm ready to multiply straight across, it looks like. Okay. Again, leave the negative in front of the x plus 5 quantity squared. And the bottom has, I guess, just the x squared minus 2x plus 4 left, comma, domain. Domain. Now, the key is domain comes from, again, everywhere. The original problem and all the steps, which is why you might notice that I kept these written the way they were the first time, okay? So even if it didn't happen to come up in the rest of the problem, you need to realize, guys, domain comes from this denominator, the original problem also. So you should know that x can't be 5 from there, even though it's also showing up here, okay? And then when you flip it over, you've got to worry about this denominator, okay? So since in a cubic, this part never factors any further, meaning it's imaginary, we don't have to worry about those numbers. We just have to worry about the one that comes from this x plus 2, okay? And so x can't be negative 2. All right, so the ones that we need to add in here, if we go all the way through the problem, x cannot equal, well, we said negative 2 from here. We've got positive 2 from here, and we've got positive 5. So I'm just going to write it this way. We can't be plus or minus 2 or 5. There you go. There would be a full credit answer for my class. Okay, we're just going to stick with that. Practice doing the full domain for me, please.